Hi everyone. In this video, let us discuss what are these different difficulty levels that we have in this project. As you can see in front of your screens, we have three levels of difficulty. We have a medium, a hard, and a challenger. So these are the three difficulty levels. The first thing that you can notice here is that the lowest difficulty level we have is of a medium level, which automatically means that we do not want easy level prompts, even though that they might create a deviation in the model, but we still would prefer medium level prompts at least. Now, you might have a question that, hey, isn't difficulty levels kind of subjective? Something that someone finds really difficult, the other person can find really easy to do. So how do you then define a difficulty of a prompt? Well, that's a good question. And that is why we have this rubric here. So we define the difficulty of the prompt based on certain categories. We have the knowledge that is required to solve that question, the ambiguity that is there in the prompt, and this complexity of the solution itself. These are the three categories which we use to define the difficulty itself. Now let us discuss what these categories are. So the first category that we have is called knowledge required. Now, in very basic terms, imagine, let's say, if a first year undergraduate student in computer science who has very limited knowledge of that programming language, who has knowledge of, let's say, some of the very most common libraries that are used in that language. So if that person can solve that particular question, in that case, that prompt is a medium level prompt. If the knowledge that is required to solve a particular question involves knowledge about data structures, about algorithms, or about any uncommon libraries that are out there, in that case, the prompt then becomes a hard level prompt. A challenger level prompt is where a very expert level domain knowledge is required, or knowledge that requires a very substantial amount of API or code context. For example, a challenger level query, think of it like this. Let's say you are working in a company, you are creating some internal product for that company that uses a lot of very niche tech stacks of a lot of different types of libraries that are not available to the public. In which case, creating anything would require a lot of previous code context. This is where challenger level queries come in. So you require either a substantial amount of API or code context, or you require like a really expert level domain knowledge. For example, if you're building a deep neural network with certain transformers and attention mechanisms, etc., those would typically come under a challenger level query. So these are the difference based on the knowledge that is required. Let us discuss the prompt ambiguity part. So when I say prompt ambiguity, you can think of it more like how much are you allowing the model to think. In medium level queries, you don't allow the model to think a lot of things on its own. You provide everything that the model needs in the prompt itself. So all the model needs to do is to just implement what you have provided. In hard level queries, you allow the model to think or come up with certain ad hoc representations of what data structures are needed, what algorithms are needed, etc. Because that, of course, is the knowledge that is required in this difficulty of prompts. So imagine this. Let's say if you have a database and you want to fetch some data from that database. So you define that, hey, I have some database. I want to fetch some data to my local system. Now, let's say if that data sort of looks like this. Now you ask the model that, hey, I want to identify maybe the index number of this particular data point from the data that I fetched from the database. Now, in this case, your objective is very clear. You are telling the model exactly what you want, but you're allowing the model to think independently on its own. The model is free to think that when it is pulling the data, which data structure should it store it in? Should it store it in graph data structure? Should it store it in queue data structure, linked list, dictionary, etc.? The model is free to think about that. Now, the model is also free to think after the data is being fetched, which algorithm to use. Should it be a linear search? Should it be a binary search, a parallelized search, etc.? The model is free to choose from any of these. And based on its choices in the data structure, the algorithmic choices might also vary. So this is where you are allowing the model to think, although you have specified a reasonable amount of constraints to the prompt itself. Now, this is a hard level query. A challenger level is then something that requires a lot of small and trivial decisions. For example, let's say if I ask the model to create a code that uses the Skyscanner API, for example. Now, in order to create a perfect code for that particular prompt, think of the very small decisions that would need to go right before the final answer is correct. So the model would need to know that, okay, what is the latest version of that API? The model would need to know what are the methods inside of that API? What are the input parameters? What are the output parameters? After that, the model would need to know which of these methods to use and for what purposes. And after all of this, it would need to think of which data structure to store the data in, what is the right algorithm to use there. And after all of this, how do I combine all of this together to actually solve the purpose of the query? There are a lot of small trivial decisions that need to be taken in order for the final answer to be perfect. If even one of them is wrong, for example, let's say if the model is not able to identify what is the latest version of the API itself, of course, the final answer is going to be wrong itself. This is where there's a lot of small trivial decisions that need to be taken. And these types of queries generally come under challenger level queries. The third we have is solution complexity. So here, basically for a medium level query, the solution is not that complex. It is easy to explain. Once you see the code, you will be able to easily understand what is happening in the code itself. So the solution complexity is kind of easy. In hard level queries, the solution complexity is hard. And in challenger level, the solution complexity again is increasing a lot. So you won't be able to understand much of the solution from the point of, let's say, a typical undergraduate student. This involves some tricky corner cases. You cannot explain this particular solution to someone who is not an expert in this field. So in which case, this type of solutions would also be an indicator that a prompt is a challenger level prompt. So next up, let us look at certain examples of these three difficulty levels that we've just discussed. So instead of going through each of these examples, I'm just going to take one example and I'm going to convert this into a hard level prompt and I'm going to convert this into a challenger level prompt. So for the first example that we have is for a medium level query. What this person wants is that this person wants to create a website. This person says that he has some data set that looks like this. This person has provided the data structure itself. This person says that he has some audio file paths. MIDI file path is basically the audio file path here. And all this person wants to do is to create a React website where each and every song is listed and there's a play button right next to that song. And once the user clicks on the play button, the song is played. That's it. That's how simple the prompt is. So in this case, the knowledge that is required is, of course, not that high. Everything that the model needs to know is already specified, which is why this prompt perfectly falls in a medium level difficulty. Now, if I had to convert this into a hard level, I could ask the model that, hey, I have some audio file paths. I can ask the model that, hey, can you convert these audio files into the binary format or generate some noise and add those noises into the audio files, merge two audio files together, and then create a website that would allow me to do all of this using the UI itself. Now, in order to complete this particular prompt successfully, the knowledge requirement is increased, the solution complexity is increased. The model now has to take a lot more trivial decisions in order to complete this particular prompt or in order to create the most accurate solution for this type of question, in which case this particular prompt would fall under a hard level query. Now, if I had to convert this into a challenger level query, I could ask the model that, hey, I have certain, instead of like using my own audio files, I can ask the model for using Spotify API, for example, or else I can ask the model that, hey, you have already added the noise to these audio files. Can you train a generative adversarial network or any type of super complex AI model to identify and automatically remove these noises from my audio files? So this is where the knowledge that is required to complete that task successfully then skyrockets. In this case, the model now has to take a lot more trivial decisions in order to successfully complete the task. And the solution complexity is going to be something that you cannot just explain to someone who is not an expert in this field. So this is why this type of query perfectly falls under a challenger level query. So these are the three difficulty levels that we have. At the start of the task, you will be provided a difficulty level that you need to comply with, and you need to create your prompts around that difficulty level. One very important thing here is the fact that a medium level difficulty prompt is actually hard to get a deviation in compared to creating a deviation in challenger level. In challenger level, you're basically asking the model to create something that is super complex. And of course, the model is more likely to do mistakes when it is creating something super complex versus the model doing mistakes in creating something that is not that complex. In which case, medium difficulty is actually harder to get a deviation in than a challenger level. So in this video, we have gone through the three difficulty levels that are there. In the next video, we will go over the 5 dimensions that are there to rate each and every response on. So stay tuned for that. That is going to be a really interesting session.